folks, this is if it's okay with you, I think we're just gonna go on. I need to go through a couple of things. So this next section, here's why it's going to be important. So I want to tie in a little bit of what you're going to get from all of the different guest speakers who are going to be coming in. I haven't heard all of them, to be quite honest, but I've heard some of them talk before. But regardless, there's always a common thread in what they will discuss with you. And so this first part is about serendipity, and I'm going to tell you a little bit about serendipity. Have you all heard the term serendipity before? And what does it mean, serendipity? If you were to just ballpark the definition without Googling it or whatever, yes?
It's like making a big discovery or something, finding something big without like effort or just by chance, or maybe by mistake.
So finding something by chance or by luck, just like randomness associated with it. Does everyone agree with that kind of definition? That's what serendipity is? It's just like, oh, it just happened. It's just like luck. How many of you think that science kind of works that way? Okay, so interesting. No one thinks that that's how it works. But I'm going to suggest to you, because why I'm giving you this sort of background and then taking you through 3 different case studies is that not only are these case studies going to lead into what you're going to get in the rest of the course, but you're going to have to, in your first short answer question that I'm actually going to give you in advance, so you'll be able to plan this out, and I'll also give you some formatting, like do you need to include like lecture 1 as a reference? You do not. So I want you to think about this when you hear some of the different guest speakers coming in. Was there any serendipity involved in their research? Or can you detect any serendipity? And what does that actually mean? So I'm going to jump in and start telling you a little bit about this. And I think you have the entire slide. So if we go back to the original definition, which is actually incorrect, so if you Wikipedia this definition, so the Persian translation for Sri Lanka is serendip, and there's a famous fable that this is sort of based on. Originally, it was thought that they were 3 princes that came out of Sri Lanka. It's not actually true. That's not the literal way that this came about. However, this story does sort of have that element to it. So there are these 3 princes who are involved in trying to help this merchant, and this merchant has lost this camel. And these 3 princes are really, really wise, and this is this fable. And these 3 really wise princes decide that based on the evidence that they have about this lost camel, they're able to, without seeing this lost camel, come up with the fact that the camel is lame in one leg, that it is missing teeth, and based just solely on their observation as well as the evidence. And so some of that is kind of like science, and this is sort of one of the first sort of fables around science. And because they're able to make all of these deductions, the merchant actually suspects that they have stolen the camel. So there's this really bad turn of events. And so as a result of that, they're taken before the king, and they're pronounced to be executed. And this serendipitous, this bad turn of luck that has happened because they're so bright and they're able to put together all of these observations actually leads to them potentially being executed. And what happens next is that based on everything that they've said, a good turn of luck comes about. And so there is a report that comes back that wandering in this desert is this lame camel, and that resembles a lot of what they have mentioned, and so they're actually cleared of these charges. And that's a little bit of what serendipity is all about. So sometimes it is a bad turn of luck, but sometimes it also means that through observation and through persistence, that sometimes you can make other things happen that turn things around. And all of the guest speakers who are going to be coming in, even ones that might look like they're leaving research and going off into a different field, and you might think, wow, that's a waste of 4 years of your PhD. Why are you leaving it before you graduate? Like there's a reason behind all of the different types of stories. Now, I also want you to understand that when you have a problem in science, sometimes it's really easy because you're building on other science that has developed, but sometimes it's just a matter of being really observant. And you're going to hear all of that in the upcoming guest speakers. And the ones that you're going to hear before your first term test, I want you to relate back. Like, do you see like elements of this serendipity, and what elements of their research can you actually determine to have some of these different elements, whether it's just hard work, good observation, or just blind luck, or circumstances that led to them getting into graduate school, or circumstances that led to them being able to do that type of research. So here are some different serendipitous moments. And some of the guest speakers, there's serendipitous moments where it's like blind luck, hard work, all of that will come together, and you'll be able to kind of hear a little bit more about this. So this is Arthur Voorhees. How many of you know him? Great. No one? Awesome. Okay, so I can make up a complete story you'll never know. Okay, so here's like what's really interesting about Arthur Voorhees. So he's born in 1921, so a long time ago. So I don't personally know him, obviously. Okay, so he was heavily influenced by his father. So his father is a really hardworking individual, but his father actually has no formal education. So back in the day, he's living in England, by the way. So back in the day, his father wanted him to work on the farm, but he noticed that his son was incredibly bright, and so he thought it was a waste for him to kind of not get a formal education, even though he didn't, and even though his father was uneducated, like his grandfather, Arthur Voorhees, his grandfather, the tradition in his family had been to just kind of work the land, but he realized that Arthur was special, that he actually was really intelligent, and he didn't want him to waste all of this natural talent. So he enrolled him in school, and he was the first in his family to actually be involved in schooling. So one of the interesting things that happened to him was that when he was going through school, he really wanted to go to med school. So I'm sure like in biology, in life sciences, a lot of you might be thinking of like med school. So he applied to med school, but he actually didn't get accepted into med school. He had good grades, but they weren't great grades. Kind of like U of T, right? So it was really hard for him. But here's this other really serendipitous moment, like in his life, like so many by chance types of moments that came about. One of the things that happened to him when he was trying to get into medical school, and he was rejected. So think about adding like 17, 18 years to this. What came about in 1938, 1939? History fans? The World War. Which one? Two, right? So World War II comes around. They actually need doctors, and so they start ramping up. So he got accepted into medical school because they simply needed more doctors. So he's around at the right place and right time. So he's smart, hardworking because of his father, coming into medical school because he's in the right place at the right time in England, where the war effort is really ramping up in 1938, 1939. And he's also really lucky because one of the most famous surgeons around at the time, Arthur Blakemore, happens to be working in the hospital that he is interning in. And Arthur Blakemore is this brilliant surgeon who decides that, hey, you know, you're a smart guy, you work really, really hard, I'm going to take you on as my research intern. And he also develops and encourages him to continue on in doing research. So after the war ends, he is now sort of under the tutelage. He is a medical doctor under the tutelage of Arthur Blakemore. And one of the things that he did was, in 1946, he's working on an experiment, and then he had misplaced a suture in a rat. You all know what a suture is. So this was a suture that he put inside the rat. And again, you have to think a little bit about the serendipity that kind of goes behind this. So what would you do if you messed up an experiment? And you know that you messed up an experiment. So he forgot, like I have a suture inside the rat. You're supposed to have taken it out, but he left it in there. What would you do? I'll tell you what I would do. Yes, Bill.
Go to the PI and apologize.
Go to the PI and apologize, sure. And what would the PI tell you to do with the rat? Probably just, sacrifice the rat. It's okay. We'll go on. That experiment is over, right? But Arthur Voorhees is a little different because, bright, intelligent, working under a really amazing surgeon. He actually takes a look at the suture. Like, I don't know how many of you would do that. You left it in there, you pull out the suture, you take a look at it. What do you notice about a suture that's been inside your body for a while? Yes?
It dissolves.
Sorry?
It dissolves.
So this particular type of suture did not dissolve. Good idea though. So nowadays, modern sutures kind of dissolve. This was not designed to dissolve. This is all the way back in 1946. Anything else that you might observe on a suture taken out of the body? Yes? Blood? Okay, similar. So he actually takes it out and he kind of holds it up to the light, and you think, wow, this is like bizarre. Like, who would do that kind of stuff? And he notices that it's like really shiny, and then he wants to know, like, hey, this suture, why is this suture shiny? So he's making these observations, and one of the observations that he makes is, it looks like there's something growing on this suture that was put inside the body, and this is kind of a neat thing. And so one of the things that he decides to do is to examine, does this routinely take place? So I'm going to put a suture inside the body, and if I put it near like a blood vessel or an artery, one of the things that happens is you get these endothelial cells, and you'll hear about these endothelial cells from Luke as well as from Tao when they come in and talk about their research. What he's finding is that these endothelial cells will migrate and will actually coat this suture. So he's kind of like forming a blood vessel by putting a suture in there, right? Is that cool? It is cool if you think about this. In the 1940s, the way that you would repair a blood vessel is that people would take blood vessels from cadavers and store them. And his idea was, instead of storing blood vessels, there was a blood vessel bank or an artery bank, and they would be kept at hospitals. We don't do that anymore because of Arthur Voorhees. He thought, let's grow our own. This is before cell culture, tissue cloning, all of that. Let's grow our own blood vessels by using this technique. And that's what his research then led him to be able to do. He started working on bigger and larger model systems, not rats, but he started working in dog models. And so soon he was able to figure out that we might be able to do this in humans. And again, he's been doing this now for about 6 years. And in 1952, one of the things that happened, again, an amazing series of events. There was this massive car accident that happened near his hospital. Again, you have to think about all of the events that kind of lead up to this. And in 1952, near his hospital, where there's this massive car accident that leads to individuals coming in, having damaged blood vessels, including arteries, the artery bank at his hospital had been depleted. There was nothing left. The patients were going to die, and Arthur Voorhees just happened to be at the hospital at the same time, and he said, if they're going to die, let's try something because, let's try to save their lives. And I've been growing up these arteries using this model system. Can we try to engraft an artificial artery? So this was the first example of how an artificial artery was used in a surgical procedure. And again, you may not think that that's serendipitous, and you may not think, for example, that the career path that you've had up until now in your fourth year have had or been shaped by a lot of things. But if you were to ask Arthur Voorhees, he would probably say the same thing, that, it just all happened, or I wasn't really expecting these things to happen. And that's something I want you to take away as a serendipitous moment. That certainly does happen. Some of our guest speakers will talk about these blind luck opportunities, like I wasn't really expecting to get into this lab and suddenly I did, or I wasn't expecting to get into grad school or med school and somehow was able to get in. So I'm also going to share you a story of John Cade. So John Cade also is a serendipitous moment. It's one that's actually making a lot of news now in 2019. So this is the 1950 to 20. So this is the 70th anniversary of his discovery. So he's an Australian psychiatrist. At the time, he was really interested in what we now would call bipolar disorder. Do you guys all know bipolar disorder? So there are these mood swings where someone is on a high and then they get really down or depressed, and this is why it's called bipolar disorder. There are two different poles, a really high pole and a low pole. In the old days, it used to be called manic depression. So you used to have mania, you got all excited, you felt you could do anything, and then you got really depressed. And as an Australian psychiatrist, he was kind of interested in developing animal models of bipolar disorder or mania. And you know how nowadays we don't use guinea pigs, and we keep using that phrase like, oh, you're a guinea pig for this experiment? In his era, in the 1940s, actually guinea pigs were in use. And one of the things that he wanted to do is to establish a theory that was gaining prominence at the time, saying that the accumulation of uric acid, and again, it's a bizarre theory, we don't believe that this is true, was responsible for actually leading to bipolar disorder or manic depression. And so he wanted to be able to take uric acid and then inject uric acid into guinea pigs to kind of let them undergo this mania. So to make them like really, really agitated, and then they would come back down, and then they would be really calm and docile. And he wanted to see this. How many of you, I won't ask. So is it hard or easy to inject urine into the blood? It's hard. Uric acid is an acid, and so in order to do this, it actually crystallizes out. And he had a really hard time to try to inject in uric acid, really concentrated form of uric acid, into the blood to induce this mania into these guinea pigs. So one of the things that he tried to do was to figure out a chemical reaction. So going back to chemistry, so we have a chemist here. So he figured out that one of the ways in which uric acid could be stabilized is if he combined it with a different compound, and it turned out that this different compound that allowed uric acid to be stabilized was lithium carbonate. So if you take uric acid and you combine it with lithium carbonate, it stays in solution longer and it's easier to be able to be injected. And so what he found, and again, this was sort of his thing, he was observant enough that when he injected in the uric acid with the lithium carbonate, that these guinea pigs, instead of showing mania, they were much more easy to handle. They were calmer, they were more docile, they became less aggressive. And so his idea was, hey, this is bizarre. I know that if I inject in uric acid by itself, because these experiments had been done, that it actually caused like severe behavioral problems, not unexpectedly in guinea pigs, but this new compound, lithium carbonate, when I inject this in, it actually calms the animals down. So he decides, I'm going to forget about uric acid. Based on my observations only, I'm going to take the lithium carbonate and inject in lithium carbonate. And so he started to see that lithium carbonate might actually be a good solution for individuals with bipolar disorder or manic depression. And he started to treat patients with this lithium carbonate. It is still in use today, and it is still a compound that is very efficacious. We don't know all the mechanisms behind how it works, but it is still used in treating bipolar disorder to this day. So again, random chance, and the fact that he was observant, it kind of resembles what we saw earlier with Arthur Voorhees, and that is actually one of the hallmarks that you'll see in all of the different researchers that come in, that they're always kind of making these associations and observations. You'll hear that particularly with Luke Dingwell, and you'll hear that particularly with Dr. Bilia when she comes in, but you'll also hear this from almost everyone, that sometimes being observant and seeing something and being able to think about it and make these associations are important. And so there's that lithium chloride, lithium carbonate, and the last one I'll talk to you about, because this also resembles a lot of the story behind Dr. Bilia, is Victor Ambrose. In some ways, he's the anti researcher. So his story is a little bit different, and his story is not a success story. It's actually an observational story. To be honest, I kind of think a lot about Victor Ambrose and his research for a while. And you have to think a little bit about his story and the context of his story and like the sheer determination and perseverance that Victor Ambrose had. So do any of you know David Baltimore? It's a serious question. You guys all take first year Bio 130. You guys have that red textbook with the cell on the front cover? Do you know any of the authors on that cell bio text, molecular biology of the cell? Right, okay. If you look at the earlier versions, this is David Baltimore. And you might think, oh, okay, great, so he wrote a textbook, awesome. But think a little bit about this. So David Baltimore is a Nobel Prize laureate. He's doing his PhD with David Baltimore. Okay, so, big deal, right? It's an incredibly big deal because Nobel laureates don't accept anyone into their labs. But also think about this. He then goes and does not only his PhD with David Baltimore, he does a postdoc, a second sort of training run with Robert Horvitz. Do any of you know Robert Horvitz? No, that's okay. Also a Nobel Prize laureate. So here's this pressure. So he's now trained with 2 different Nobel Prize laureates. So he knows like everything that you need to become like an amazing scientist. And while he's doing this work with Robert Horvitz, he starts working with C. elegans. And his job as a postdoc, because he's had all this training as a postdoc, is that he wants to be able to inject in RNA into a cell within C. elegans. And this is actually a routine procedure. You can do it. I've done it. It's not that difficult. It's not that challenging. And he's been doing this now for 6 years. And all he wants to do is to inject in this RNA, and then he wants to see the expression of that RNA in this cell. Okay? Not crazy, because David Baltimore is a cell biologist, molecular biologist. Robert Horvitz is a geneticist. He's been doing this technique, and he's failing at this, like over and over again. Every time he takes this RNA, injects it into C. elegans, hoping to see expression of that RNA in C. elegans, he's failed. And so on and off, like to me this is incredible. So on and off over the next 20 years, he never forgets that experiment. Every lab that he goes to, including like his own research lab, he does this same experiment over and over again. Would you do that? If something didn't work for you, would you just give up on it? To be honest, I would. Like 20 years, that's a long time. Like, thank you med school dreams, but it's time to move on. That ship has sailed, right? So he doesn't. He actually persists in doing this. And in a little bit, you'll see that it kind of reflects back on what Dr. Bilia is going to come in and talk to you about, because her story runs over several decades, and she's been interested in particular genes and particular proteins and how they work, and they didn't really have a great story. It kind of was a failure for a while, and then some other things kind of happened. So it turns out that one of the things that he discovered, mainly through like just brute force work, he did not win a Nobel Prize for this, by the way, brute force work, one of the things that he discovered is this idea that cells actually have a mechanism. Oops, oh, I thought I had another slide. These cells have a mechanism known as RNAi. Have you heard of RNAi? Yeah. And the reason why his experiment failed over and over again, that there is a short hairpin RNA that exists within C. elegans that actually causes the LIN4 to be, the RNA to be degraded. So every time he tried to inject it in, it underwent RNA interference. He could not explain it, but he knew that he was a good scientist. He didn't give up on himself, and he kept going, and he kept trying it, and he asked other people to try it. They all failed too. No one could explain why this was going on until they worked out a mechanism. Yes, the RNA is getting in there, but there has to be something that causes it to be broken down, and they came up with this brand new idea of RNA interference. That took 20 years of work. Again, I would think that most scientists, especially nowadays with like funding issues, most scientists would kind of give up and say, that's it, like the experiment didn't work, we'll come back to it, we'll think about it later, but this is like the type of perseverance and the type of problem solving that makes some scientists actually very unique. They're not willing to kind of give up on something that they know is right. And so now it's all into like RNA therapeutics. Some of you might be interested in this topic, and some of you might want to do this sort of as your group topic. Nowadays, like the hottest technology is what? Molecular cell biology. What's everyone talking about? CRISPR-Cas9. So also like an accidental discovery too, as well. So like yogurt going bad, that was a chance discovery that led to the discovery of CRISPR-Cas9. I'm not going to go into that, but it might be a technology that you're interested in. And the thing that is actually, we won't go through all of these slides. It's not about the data on these slides. Most of you have heard of induced pluripotent stem cells, iPS cells. So some of you might be interested in like the topics that lead to iPS cells. In its own way, this is an intriguing story as well. And you guys can probably tell me the story better than I can. So actually, these ideas of stem cells originated here in Toronto. And this idea that every single cell has this ability to differentiate into another cell type in the body, but they all begin as a stem cell or a totipotent stem cell. This really bothered a scientist who came up with the Yamanaka factors. And he wanted to know like how to go back to that primordial state. And if you think about this, do any of you know when he won his Nobel Prize? So he published this massive paper back in 2007. Do you know how long it took for him to get his Nobel Prize? Roughly? Guesses? Yes? 8 or 9 years. So this was such a big discovery that they awarded it to him. I think it was 5 years before he got it, or 6 years. So a very, very short period of time. And since then, so this is when he first published his paper, back in 2007. And then when you look all the way back now, so some of the first experiments were done there. So we're now using this, and some of you may have seen this. We're now using iPS cells made from skin cells to actually create cornea to be able to transplant. And this is now done in humans. So over the very, very short span from 2007 to clinical trials that are done in humans in 2019, think about the amazing work that all of these researchers that look at health and disease, like all the things that they're capable of doing. And I know that this will be a really popular topic, like iPS cells. If I'm going to make one suggestion to you, and it's a great topic, is to pick a particular system or a disease model, whether it's in the nervous system, whether it's about organ replacement or transplantation. Like think about how to relate it back to a disease, and you'll find it a lot more interesting. Do you have any questions about anything that I just covered? No? Do you still want to be scientists? No? So like, yes, do you have a question? Sorry, can you?
The information on the slides that you skip, is that tested?
No. So I'm gonna actually give you the question in advance, so you can think about it when you start hearing the lecturers, the guest speakers that come in next week. But I want you to be able to take a little bit of the different ways in which serendipity work in science, whether it's clinical science or translational science or just pure benchwork science, and then relate it back to like the guest speakers that you'll have coming in. So what elements of that, like does it kind of resemble like just the perseverance, the story didn't work out well, and like the microRNAs and the RNAi, like you don't need to worry about the biological mechanisms. Any other questions? No? Nothing? Are you going to be a more talkative class over the semester? I hope so, because the guest speakers, they really want you to interact with them. So they're coming in here not to talk to me, they're coming in here to talk to you. And they want to be able to inspire you to go on to clinical science or into research science. They're not coming in to talk to me. Remember, it's all to talk to you. So please interact with them, ask them questions, whether you feel more comfortable coming up and talking to them after, or inviting them out to have like a coffee as a group with your group, or by yourself. Just use these opportunities to kind of figure out like what might interest you, where you're going to go next. And if you're not sure where you're going to go next, like find out a little bit more about their story. Any other questions? No. All right, so it's 11:30. 11:30. So I think what I'm going to do is I'll just leave it up to you if you want to hang out here, figure out like who's going to be in your group, how you're going to communicate if you are, what kind of papers you are going to find, or if you want to just leave early, please feel free. Next week we are going to have guest speakers coming in. We will record it, so I'm going to post all the recordings for you. If you can think of anything else in the interim that you need to succeed in this class, let me know. What else do I owe you outside of posting the take-home question in advance? Is there anything I'm forgetting to post for you? Recordings, question, anything else? No. Okay, again, the sound, yes, yes.
For the speakers coming in, if they're like actively involved in research, could you post some of their like?
Yeah, yep, for sure. So I will, that's a great suggestion. So I'll post some of their biographies or links to their research lab pages in advance. So, and I'll also, like even for Zaid, he has like a web page, My Exome. You can read a little bit about his startup company as well. Okay, any other suggestions? I feel like I'm getting the silent treatment. It's okay. It's all right. It'll be okay. Yeah, so I'll leave it up to you. So that's it for today, and hope like every class you'll come in, get excited. There will always be coffee because I see some of you yawning. It's a rough go in the morning, especially like on a Tuesday. But I'll see you all back here next Tuesday, and if you have questions, please feel free. I'm going to start looking over the orange sheets this week. So if there are things that I want to just catch up with you about, I might just reach out to you, so don't be alarmed. It's all just trying to get to know you better, all right? So, yes?
Is there a discussion board? I think I read in the syllabus that...
Yeah, so if you know like your group members, etc., like you can start posting. If you know like your topic, if you need more people to join your group, I'll set that discussion board up for you. So great, so that's another thing I need to make sure that's available. So practice question or not the practice question, the actual question for the take-home term test, the lecture recording links, and then biographies, and then setting up the discussion board. So I can't remember anything more beyond 4, so that's it. So I'll see you all like next Tuesday, and have a good week, and you're welcome to stick around and grab some snacks, or just grab snacks on your way out.